All big problems are tiny problems stuck together. So today we're going to get started with something called computational thinking. When we say computer science is more about ideas than technology, what we actually talk about is human thinking skills, the practices, perspectives, and concepts we humans use to structure problems in a way that a computer can solve them. This is what computational thinking is all about. Computational thinking is something that people do, and it includes the ability to think logically, algorithmically, break problems apart and spot patterns. When you are playing music, solving an equation or making crafts, you are using your computational thinking skills. Computational thinking doesn't have an exact definition. Sometimes the list includes things like automation, data, analysis, parallelization, and simulation. In this episode, we're not looking for a perfect definition, but rather trying to help you see how to connect computer science to the things in the real world, as well as enrich your computer science teaching and learning. Computational thinking doesn't need to replace anything in your classroom. It doesn't require any additional gadgets or gizmos, and odds are you're actually already using it in your curriculum. It's the perfect way to get started teaching computer science. Computers, even though they seem smart, are actually kind of dumb. They follow instructions given to them. So today we're going to practice computational thinking with an activity where we will be teaching the computer to brush its teeth. So the task here is to instruct the computer to brush its teeth. The other student is the computer, the other the programmer. Let's see how things go. So which one is the programmer, which one is the computer?
I'm the computer.
Yeah. Okay, so you're the programmer. What is your first command?
Take the brush.
How do you define the brush?
Take the brush from the cup.
Yeah, and what kind of a brush?
Take the yellow brush from the cup.
Good. And girls, you can get started too.
Okay.
And what happens then? What's the next step?
Take the yellow brush up. Stop. No. Take it down. Stop.
Good. Then what happens next?
Take the yellow brush to your mouth. Stop. Now try to stop. Take a bit down. Stop. And now put it.
What happens next?
Start to brush your teeth.
Good.
Okay, put it. It's like a rectangle. Now stop.
Do you need to open your mouth? Could you give him a command?
Open your mouth.
Good.
As well. Now brush your teeth.
Yes, he's a good computer. What's happening here?
Now take the white toothbrush from your mouth.
Beautiful. That was really excellent job, you guys. But you know what? You forgot the toothpaste. Uh-oh. Through exercises like this, we learn how important being precise and defining things well is, and how hard it is to take into account all the situations a computer might run into. We also learn about working together, a trait so important in programming it has a special word, pair programming. The children learned about dealing with failure, debugging we call it, when you look carefully through the code you've written and use logical reasoning to explain where the error is. And very importantly, they learned that programming is very creative. There is no one way to solve the problem. What else? Well, they went through 4 of the computational thinking concepts we are going to be focusing on today. First, we broke the task into pieces. We spotted similarities, things that belong together. We tried to come up with a name to describe these things, and finally we made a step-by-step instruction on how to brush your teeth. We'll start with decomposition, which is breaking a problem into parts or steps. This is something students do every day. They analyze a story, work on math problems, plan the route to the school. In programming, code is often broken into chunks of code you can refer to. Decomposition is important because it allows several people to work together on a team and makes the code more easy to update. So in the very beginning, the kids needed to figure out the different parts of the problem of brushing your teeth. toothbrush, toothpaste, water, brushing, spitting, movement, and look at each one again through the eyes of the computer. The next thing we'll talk about is pattern recognition, things that are similar to one another. Recognizing and reusing patterns is something we do in our everyday lives, whether it's when we learn a new language, look at a piece of music, or study the patterns in economics. After a little time coding, you will recognize that you keep writing similar blocks of code time and time again. These common solutions to common problems help keep your code structured and easy to work with. Even though these pastries all look different, the ingredients are similar. Finally, let's talk about abstraction. It's at the heart of computer science, and it's all about capturing the important structure of a system or a problem, but not worrying too much about the details. It's the ability to generalize patterns and trends into rules, principles, and insights. A map is an abstraction of the real world. It can't be too vague, but can't show every little rock on the ground. Chemistry abstracts the properties of chemical bonding so that we can have a discussion about it. In math, we abstract or generalize formulas when we use variables instead of numbers like y equals x2. Imagine we wanted to change the color of the toothbrush. Instead of going to 7 different places in the code, we can just fix it at one place. That's a good abstraction. And this brings us to algorithms. We'll talk about algorithms in more detail later, but at the end of the activity, the children actually did create their very first algorithms. A sequence of instructions or a set of rules to get something done. Algorithms, unlike programs, are written for humans to read. What is computational thinking and what does it mean to teach it? Seymour Pappert's talking about introducing tools to think with, and Jeanette Wing is talking about understanding problem solving with computers, but I think they are both referring to the same thing, finding the aspects of computer science that are simultaneously personal and universal, making computer science approachable and lowering the barrier of entry. Computational thinking is something that will help you and your students to start to recognize how computer science skills apply to other domains and how you can sneak in thinking around computer science into arts, physical education, English, and math. Computational thinking gives an understanding of the artificial world, but it also gives a new way of understanding the natural world.
Dear Linda, what is code? And how do you learn programming?